Hi everyone. As AI continues to evolve at a breakneck pace, the line between human and artificial intelligence is growing more and more blurred. Have systems like GPT-4 already reached the AGI threshold of human intelligence? Could a government agency or a tech giant have created a secret AGI in a covert lab? Stay tuned as we attempt to answer these questions. So this video has 3 parts. What is AGI anyway? What's left before we have AGI? And has AGI already been created in secret? First section, what is AGI anyway? Well, AGI is artificial general intelligence, usually defined as AI that has human level performance. But actually narrowing in on what exactly that means is pretty difficult. A series of tests have been proposed to define whether a system is actually intelligent, which we can use as a proxy for AGI at the moment. The most famous test is the Turing test, where an experimenter conducts a text conversation with a human and also a text conversation with an AI. If the experimenter can't easily tell the difference between the human and the AI, then the AI is said to be intelligent and have passed the Turing test. This is a pretty unsatisfactory test in various ways. I think it's pretty safe to say that chatbots like ChatGPT and GPT-4 have now passed the Turing test. You can chat with it for a long time. Although it may not be exactly like a human, those entities are clearly planning and reasoning and having memory, and they have a very strong command of English or whatever language you're speaking to them in. That's only a subset of what a human can do, right? Humans can actually move around and have physical embodiment in the world, as well as learn over the long term and carry out a wide range of other tasks, learn in real time as well. A few other tests have been proposed as well to measure whether an AI is AGI. One of them is the coffee test, where an embodied machine is supposed to enter a typical home and search for all the ingredients necessary to make coffee, find the coffee machine, use water appropriately, brew a coffee, and bring it to a human. The third test is to have an AI actually enroll in a university degree, take courses, pass exams, and so on, and carry out all the same activities that a human would during the course of a 4-year university degree. And finally, the employment test is to have an AI actually perform an economically important job to the same degree of competency as a human would. Obviously, none of these tests are very precise because it's very hard to narrow down exactly what it means for an AI to act like a human or to be a human or to be intelligent. Of all of these tests, like I said, we can definitely say GPT-4 passes the Turing test. I don't know of any robots that pass the coffee test, but I suspect we're really not far away from that, especially with multimodal models coming from Google and so on. As for enrolling in an entire university degree and trying to pass all the classes, I don't think we're quite there yet. It probably needs a lot more long-term memory and explicit retraining and so on. And fourth, for the employment test, I actually personally know of some jobs that have been lost to automation, primarily copywriters and so forth. So maybe GPT-4 is already passing that employment test as well. But I think it's safe to say that right now, the majority of human jobs still require a human. A very important aspect of these definitions is whether they're supposed to apply to one case, to some cases, to the majority of cases, or to all cases, right? So as we get smarter and smarter large language models, it's conceivable that more and more jobs will start to get replaced by it. Perhaps when we get to the point where a majority of jobs can be automated by AI, maybe that's a true pass for the employment test, the fourth test there. But I'm sure there's going to be some people that won't be convinced until every single job can be automated. So it depends how you take your definitions. Again, from my perspective, GPT-4 seems to pass a lot of these tests, but only in a small set of cases. We're not yet at the point where a majority of jobs, for example, can be automated by the AI model. So I would say, looking at these, that GPT-4 is not an AGI. And actually, the creators of GPT-4 also agree that it's not yet an AGI, although it's very interesting that we're actually having this conversation about it. Second section, what's left before we have AGI? The prospect of building an intelligence from scratch involves a lot of different skills. And originally, people thought that these might be walls for AI development. In other words, the technology could advance really well until it hit this wall where it had to solve some other aspect of intelligence. According to Anthropic, some of these walls included multimodality, logical reasoning, speed of learning, transfer learning across tasks, and so on. But we've really blitzed through some of these walls already, including multimodality and logical reasoning. Anthropic believes that there are no hard walls in place that won't take more than a few months or whatever to work through if AI researchers are determined to do so. There's a sort of scaling hypothesis around AI, which basically says, hey, if you scale up the model by continuously training it for longer and longer periods of time and adding more and more data, then a lot of the properties that you want will just arise naturally. For example, between GPT-3 and GPT-4, there was an increase of about 250x, 250 times in the amount of training data and computation time used. It's correspondingly more powerful. And the idea is you can continue to scale up and scale up and scale up until you have a model which is actually true AGI. Again, we don't know for sure whether this is going to work out or not, but there's still certainly room for growth in terms of how much computing power we can throw at the problem. In fact, I read one estimate that in the next 5 years, we'll be able to add a 1000x increase in the amount of compute dedicated to these tasks. The jump would be far larger than the jump between GPT-3 and GPT-4. So that's something to think about. I want to show this XKCD example as well, which shows how it seems very, very slow at first, and then eventually you start going from like, oh, it's about as smart as a chimpanzee, to, oh, it's about as smart as a dumb human, to, oh, it's about as smart as Einstein, right? It's potentially not that substantial. Again, GPT-3 passed the bar exam for becoming a lawyer, passed the bar exam, but ended up in the lowest 10%. GPT-4 tried the same test and passed it in the top 10%. So he went from bottom 10% to top 10%, just between the one model to the next. So if GPT-4 can replace, say, 1% of human jobs right now, how long will it really take before it can replace 99% of human jobs? So in my opinion, AGI is not really a well-defined point. It's too amorphous, too hard to define. It's more like a continuum, where you end up with something that is only a little bit AGI, and then you end up with something that is very much so an AGI. And we've already started on that continuum because we've already had jobs start to get replaced by AI systems. So do we already have AGI? I want to note as well that it's very hard to find information online about what some of these walls or some of these hurdles might be to developing more and more sophisticated AI. And there's good reason for that. Most people are trying to not talk about these things so that it doesn't become obvious and then these problems don't get solved even faster. Right now, AI development is happening at breakneck pace, right? And we know that the AI alignment problem has not been solved. And if we get too far ahead of ourselves, we might end up in a lot of trouble. So sorry, but it's a little hard to outline exactly what's left before AGI because first of all, people don't really want to talk about it. And second of all, like I said, it's more of a continuum, which we've already started on and which we are going to fly through really rapidly. Third section, has AGI been created in secret? A lot of people say this, right? Well, look what GPT-4 can do. Imagine what the US government has at their disposal, for example. Or maybe some company could have created an AGI and just isn't telling anyone because it's so dangerous or so powerful. I actually don't think it's likely. I think GPT-4 represents the cutting edge of what any human has been able to do. And I'll tell you why in this section. So first, let's talk about how government grants work, especially in the US, but also elsewhere. Organizations like DARPA and ONR, the Office for Naval Research, and so on, want to get research done, but they don't do it by hiring researchers to work directly for the government. They do it by creating contracts which universities and research labs bid on for the privilege of receiving that money to do the work that the government wants to get done. In the US, there are some entities like the NSF, the National Science Foundation, which do supply money for fundamental research. In other words, it doesn't have to have like military applications and so on. Majority of funding that comes in, at least for computer science, is in the form of these like DARPA contracts. Again, the research doesn't have to have direct military applications, but entities like DARPA are kind of trying to drive the way towards things that they find valuable. And by providing the funding for the research, they also have the right to take that research and use it within the military directly. Other countries tend to not have as much money available for funding research, and they tend to focus more on that basic research or that fundamental research, as I mentioned. But most of the big important projects in the US will include the involvement of an entity like DARPA. What this means is that when the government wants to do something big, like create artificial intelligence, they're probably going to actually contract out pieces of it to different universities, because there are way more professors at universities and so on than the government could get to work for it directly. And that means that word of this type of thing gets out, right? It's very difficult for the US government to actually embark on a big new direction of research without involving the actual academic community. And this is why I don't think the government actually has AGI that it has created on its own, because it simply doesn't really have the manpower, and that's not how it's typically structured. But let's talk about academia for a minute, because I was saying that the government is relying a lot on academia to get things done. Within academia, AI researchers always come up against the big barrier that they don't have enough data to actually train the models that they're interested in. And often it's hard to afford the computation power needed as well, but the big problem is data. So they have to make partnerships with industry. You get PhD students that leave academia and do some internships at big companies like Google and Facebook, and maybe they get access to some of that data and bring it back to their lab. But I can tell you that most PhD students that are actually working in artificial intelligence are either considering becoming professors, or they're going to work at these primarily very large companies where they have access to a lot of data. The government isn't actively trying to recruit those people because they can't compete with the salaries for big companies. And until now, they haven't really had that much work to be done in the AI space. I'll contrast that with cryptography, for example. It's actually pretty hard if you study like theoretical cryptography to get a job in industry, and security is of extreme importance to the government. So the government, specifically the NSA, would typically hire almost all of the cryptographers that were graduating. They would either become professors or continue to work in academia a little bit, or they would go work for the government, at least at some point. So yes, the government does have a lot of cryptographers. The NSA does have a lot of capabilities, partially because they were the primary employer for this type of talent. But the government doesn't have that for artificial intelligence. These people are all going to work for private companies. Okay, so we talked about the government, and we talked about academia. Industry could also potentially have created an AGI and not told anyone. And actually, that's sort of what happened. Google actually invented the transformer technology in 2017, and in 2018, they expanded it, and they actually created a large language model internally, but they decided not to turn it into a product because they were worried about its tendency to hallucinate and make up information. Google is very concerned about their image as a provider of search, as a provider of valid and accurate information, so they didn't pursue that direction. But as soon as OpenAI, the second entity to essentially create a very large language model in this space, created theirs, they realized there was commercial potential. They didn't really have an image to maintain. I mean, they kind of are associated with Microsoft, but they're also detached from Microsoft, right? Microsoft gives them money. So if ChatGPT did something really bad, it wouldn't really reflect badly on Microsoft. When ChatGPT was publicly released, the race was on, right? Google had no choice but to take their large language model and to try to develop that technology as well. So what I'm saying is industry is under a lot of pressure, but if something has no reason to exist in their portfolio, but if something doesn't directly add to their products, they're not going to pursue its creation, including the creation of an entire secret AGI, which would take immense amounts of computation power and data to create. So yeah, that's why I don't think we actually have a secret AGI out there right now. The government doesn't do these types of things on its own. It contracts out to academia. Academia hasn't been creating these types of things on their own. They also don't really have enough data. And industry doesn't have the reason to pour all that money into something and not have it come to fruition. GPT-4 is probably the best we've got. And actually, there's another argument for that as well, which is that the most powerful Nvidia GPUs that are available right now are A100 GPUs, which are the successor to V100 GPUs. They have 80 gigabytes of memory each. And the most GPUs that you can put into a standard server is 8. So you can get 8 80 gigabyte GPUs in one server at once. That totals 640 gigabytes. Most large language models are heavily memory bound, meaning they will take as much memory as they possibly can. And GPT-4 presumably takes up the entire 640 gigabytes of memory, because those are the nodes that OpenAI is doing inference on. So without building a distributed model where it runs on some GPUs on this server and some GPUs on that server, which is an order of magnitude more difficult, GPT-4 is essentially the largest you can possibly make a model right now without having custom hardware and so on. Bigger doesn't always mean better. In fact, smaller parameter counts like those used in Lambda are doing really well, of course. But I really do think it would be quite difficult to make something more powerful than GPT-4, especially on really short timelines. So that's why I think that GPT-4 is our most powerful model right now. Of course, if companies have their way, it won't stay that way for long. So finally, in conclusion, I don't think there's a clear-cut measurement for AGI. It's more of a continuum, and we have already started onto that continuum with GPT-4. In fact, just yesterday, I heard on the radio an interview with a Bloomberg analyst talking about how AI is taking a lot of jobs and also disproportionately affecting women. So there's that, unfortunately. And as we are at the start of this AGI continuum, there don't really seem to be any insurmountable walls that might slow us down from improving. Well, there are walls, and people don't really like to talk about them, but when you have the resources of a large research group, those walls are not going to stand for long. Okay, if you enjoyed this video, we talked a lot about ChatGPT, so check out this other video I made about why ChatGPT caught everyone by surprise. That's all I have for today. Thank you very much for watching. Bye.